Greetings. Welcome back to Terraform Time here on the PagerDuty Twitch channel. My name is Scott McAllister. I will be your host today. I'm a developer advocate here at PagerDuty and the Terraform Provider maintainer for PagerDuty as well. To get things started, I always want to remind folks that this is just part of a variety of shows that we offer here on the PagerDuty community and PagerDuty's Twitch channels. Terraform Time is every Monday at 1 p.m. Pacific. And then we also have some bookends on your week. We have PagerDuty Garage that happens in the morning on Monday, and then PagerDuty Garage that happens again on Friday afternoon. So if you're on the East Coast, it's a good way to start your week and end your week with Mandy Walls. She'll be talking about various aspects of the PagerDuty product, PagerDuty API, and just various things that relate to working with PagerDuty as a developer. With Terraform Time, we go over various topics dealing with Terraform. Today, we'll be talking a little bit about the Terraform Provider and how to interact with it. For the last few episodes, we've been talking about developing or fixing some issues on the Terraform Provider, and didn't make a lot of progress there, but such is the life of being a developer, software developer, if you know what I mean. So today, what we're going to be talking about is something that is a recent discovery that I've made, but I wanted to make a few announcements first. So the live shows that we have on our Twitch stream, these are the regularly scheduled episodes of PagerDuty Garage and Terraform Time every week. And then also, we have my cursor. No, we have, get that out of the way. Oh, interesting. And we also have the quarterly Terraform Roundtable that is approaching. That is coming up on April 26th. The Terraform Roundtable, quarterly roundtable, is an opportunity for users of PagerDuty and Terraform to get together and talk with one another. These episodes of Terraform Time on Twitch are more of an opportunity for me to talk to you, for me to share with you some ideas that I'm going through or interesting discoveries. That's what we'll be talking about today. And with Terraform Roundtable, the idea is we want to get folks onto a Zoom call who are using Terraform to manage their PagerDuty accounts and have you folks have an opportunity to chat, let you ask questions, see what best practices you're doing. If you have any issues that you're trying to get through, maybe not necessarily technical issues with the provider, you can share those as well. I'll be there. I'll be taking copious notes of those types of issues so I can get them in front of the right engineering teams at PagerDuty. But also maybe you're just having issues trying to get your configuration just right, to have it run properly, to have it run efficiently. And so the quarterly roundtable that we have that's coming up on April 26th is your opportunity to talk with other PagerDuty and Terraform users. That way you can get their ideas, and collaborate. I like to think of it as sitting around in a room together, although across the world, and our chairs are circled and we're just chatting, right? We start off, hi, my name is Scott and I use Terraform, that type thing. No, you can, but we usually keep it light, and it's a good opportunity for everyone to get connected and to talk with one another. So we have the quarterly roundtable there on April 26th. If you have any topics for Terraform Time, please drop them in the chat. Reach out to me on Twitter. You can find me at @McAllister on Twitter. And absolutely would be able to talk about those topics. Even if you'd like to be on the show, love to have you on the show. If you want to get on and show us some of the cool things you've done or some of the cool configurations you've made using Terraform and working with PagerDuty. I can also even expand my horizons. And we talk about Terraform because that is the one that we see most people using and most people talking about. But we're willing to talk about other infrastructure as code tools. So if you're using anything else, if you're using Pulumi, something like that, or AWS CloudFormation, something like that, you can absolutely, we can let us know, and we can have topics about that. We can have episodes about those different tools as well. So, but right now we'll focus on Terraform because that is where the chatter is, and that is where a lot of our user base is. So, as I mentioned, the last few episodes, we've been talking through some issues, and we got kind of bogged down talking about the same issue multiple times, and then discovered that I actually don't know how to fix the issue that we have. I need to update that ticket. But today I want to take a break from looking at problems and look at something that can solve some problems. And so this is a library that I've discovered recently that allows you to create HCL, which is HashiCorp configuration language, using Go. And let me share a reason why I needed to find this, or a reason why I was looking for a library to help me do this. A little while back, I needed to create let's step back up a little bit. I'm a developer advocate, right? As a developer advocate, I work with people who are working with the PagerDuty API. Whether you're a customer and you're using something like Terraform to automate things or to make things a little more sturdy, or if you're a partner and you're building an integration and you want me to take a look at that integration and test things out and kick the tires and see that it works as expected before we list it on our integration directory. That's another part of my job that I do. As part of that job, I need to have a PagerDuty account that is full of data. It has to have, and it depends on the different scenarios, but I need to have data created either to, you know, have an incident happen or have services that are there to be able to connect to an integration, have enough users to kind of test out if an integration lists all the users or lists all the services. This is actually a key point that trips up several of the partners that are building applications and building integrations. Is they'll build an integration that they make a get call to an object on the PagerDuty API, say like services or users, but they don't take into account that our API actually pages those results to protect our servers. And it's a common practice that we follow. We page or group those results so that we don't take all of your users. Say if you had 10,000 users, we're not going to send you 10,000 records back in a single request. What we'll do is we'll send back 25 by default. Or you can even change it up to get to 100. You can change a URL query string parameter to get you up to 100. I believe it's limit is what it's called. And to do that, then you can take that and kind of loop through API calls and get those 100 blocks of users or 100 blocks of services, and those will come back to you and you can process them on your side. So you can absolutely get to the information, but it helps protect, the PagerDuty service and the PagerDuty platform to, not, have the whole thing fall over when people are making gigantic calls. And so with that pagination, a lot of times an integration will say, hey, select a service to tie this integration to, or select a user from this list. And that list won't show all the services because it's only showing the first 25. To test this out, if I see that there's an integration that is basically pulling back a list of services or a list of users or a list of something that I know has paging in it or pagination in it, then I want to have that account and I want to create at least enough of those resources to test out the pagination to see if we're really pulling back all of the different issues or all of the different services. And so in my case, I needed to do something that I needed to create a lot of services. In this case, I had an integration I was testing out and I needed to create more than, 50 services, I think. And so, I wanted to test more than 50 just to see. I was going to start there because, as I mentioned, with the limit URL, the query string parameter. In fact, let's pull that up really quick. This is all about learning time, isn't it? Except for our developer site is not happy. Interesting. Well, gosh. That's going to hurt things if I can't get to those sites. Let's see. Let's try this one more time. Let's go there. Let's pull it up in a different. Let's use a different browser. Let's say Firefox. Weird. So something's wrong with my Chrome. I guess I will need to troubleshoot that after this this episode. So we'll look at my Firefox. Maybe Firefox is our knight in shining armor today, helping us get through this little funny behavior in Chrome. And so in our developer documentation, you can find. Let me bump that up a little bit for you. Let me know if that resolution is not big enough, and I can bump that up even more. And if I come into here and go to our REST API and we look at our pagination, you can see what I was talking about. We have a default limit of 25 records returned when you call the API, when you're getting a list back of something. And so you can get 25, or you can actually increase that limit. I believe it's going to tell you. Interesting. Okay. Maximum upper limit of classic pagination. The REST API permits retrieving a maximum of 10,000 records via pagination. That is to say the sum of the offset and the limit. Parameters cannot exceed 10,000, or the REST API will respond with a 400. If the total is greater than 10,000, then not all records in that set can be retrieved. As an alternative, you should constrain the results to under 10,000 by using a filter. Okay, good to know with that. But here, up here, so that was a little side note on limit. So if you have something that's over 10,000 records, you'll need to apply a filter to it if you want to get all the results back. So it gets under 10,000. That was something I was not aware of. So today I learned. And here what you'll see is that the limit is for classic pagination, which is what we'll be talking about today. And that's what most of the endpoints at PagerDuty follow. They talk about another type of pagination, but there's very few cursor-based, I believe it's called. There's very few endpoints that follow that yet, so we won't be talking about that today. And it's defaults at 25, but you cannot exceed 100. So you could change the limit if you want to up to 100. But for me, when I test something out, I go into it and I just say, okay, let me try to find a service that's over, 25. And then if I can find it, great. Then I'll up it to 50. Then I'll up to 100, and just to see if I can get to that service. In this case, what I had was an account that was practically brand new. I had to I had to kind of flush some things out of my account. If anyone who's on the, in the episode or in the audience today knows, if you have like an account that you use to demonstrate things, but then also to test things, and then also to try out things, and then also to just, explore, it's like your bedroom as a teenager. It just gets more and more and more cluttered. You know where everything is, but you can't find anything. And so I had to finally just clean out my account. It came down to that. And so I completely started over, brand new account, brand new everything. And what I have here is an account that only has 2 services. So I couldn't really test out how to, if this particular integration I was testing out, I couldn't see if the pagination was working, if they had the correct pagination, because I only had 2. So I needed to create I was going to shoot for around 50, maybe 100 different services. And I played around with some scripting before. I'd written some Python that actually there was a blog post I wrote, and I'll show that blog post real quick. Let's see. If you go to dev.to, maybe you won't. Maybe Chrome is just not going to play nice today. I'm actually going to. Oh, nope. No, I'm not. No, I'm not. Because Chrome is running in this. Cancel. All right. Fine, Chrome. I'm going to go play in a browser that might work. Burn Google. Okay. So that was burn, comma, Google. That wasn't telling people to burn Google. Anyway. Let me see. Where was I going? I totally lost my train of thought. All right. So I'm going to go to my account. No, I had my account. And so what I have here is I needed to create, oh yeah, my blog post. So dev.to, and we'll come here and we'll say PD community. That's where this was. And this was a few months back. I actually wrote this one. And in this one, I had some Python code I'd written that basically went through and created an HCL file for me. And that's fine, right? It worked. It wrote text. It didn't do any checking because it had no idea the type of file it was writing. It was just building a file of text that I said, build it in this format and let's make some HCL. And so it was going to build like a resource or the PagerDuty service and go through and we could add a little bit of automation to it, make it loop over this bit of code, throw in some IDs to make sure that it, or throw in like an ID to make it to like number it, to change the name a little bit. And it was fine. It worked, but I felt it was a little sloppy and there had to have been some way to write this in a way that I could kind of, know where the library knew that I was what I was trying to write. And I explored a little bit and found that HashiCorp and the folks at HashiCorp had created this library called hclwrite. And I mean, truth be told, since I've gotten into Terraform Provider development, I've really gotten into Go. And the Go language is a super fascinating language. Highly recommend it. And I've been trying to find other reasons to start using Go in other projects. And so this was a particular project. I thought, all right, let's see if I can do this in Go. And since Terraform providers are written in Go, it would make sense that there might be tools to write HCL in Go. And so I found it, and hclwrite, of course, was not available in that browser. So hold on just a moment. Is a package you can find on go.dev. And it has all these amazing features. And as someone who's pretty new to Go and not real versed in Terraform, to be perfectly honest, before I got involved here at PagerDuty, I was a little baffled by it because I was like, wow, there are so many different things I can do with this, but I don't really know what any of this means. And so I had to kind of kick the tires on it a little bit and kick around and struggle in the dark and find a few things that made, that would work. This example was a great start. It's a great way to kind of see how things were put together. And so I used this example actually that they showed me to get started on how I did things with mine. And so what I needed is I need to create in my PagerDuty account, I needed to create a lot of services. And so when you look at services inside of PagerDuty, the thing that you'll notice is that a service, let's go here. So to go to terraform.io. Wow. That doesn't look good. I'll need to go find that. That looks like a bug too. Hold on. You all get to see this live. I want to make sure that that's just not the internet being weird. Service dependency. No. Okay. Maybe that was just a bad link. Let's put it up. Let's chalk it up to that. See that it was a bad link, and we'll move forward. If you look at a service, there's a few things that you'll see, and that makes it a little more complicated to build automatically than just looping through something and giving it a name. And in this case, there's a required fields, and one of them is this escalation policy field. And so with escalation policies, you need to have an existing escalation policy that you can tie to that service whenever you create one. And so that was a kind of a tricky part that I needed to figure out. I needed to figure out not only how to do strings, but how to do references to other resources or variables, reference variables. As I like to call them reference variables. Their documentation calls them resource references. However it works in your brain, that's how you can keep it. But that's where I keep things for me. And so with me, I needed to find something that allowed me to do just that. So let's go over to this HCLWrite library. Rather than show you all the different resources that I struggled through to find my information. And I mean, I don't want to, I'm not trying to bash anybody and about the resources that are available. It was just for my understanding and my learning. I needed to have things a little bit more spelled out, I guess. And so that's why I'm doing this today to kind of help show what I went through. And so what we're going to do is we're going to talk through a few of the different features of this library. In here, we'll zoom in just a bit. That might be too much. Too much? Maybe not too much. All right. Some things that are important. First is that HCLWrite is a package provided by HashiCorp. It's inside of the HCL package that is provided by the company. Hand in hand with that product is also something called HCL syntax that you'll also want to use as an import or dependency. And also you have this, the ZCL conf package. I look at this thing, every time I look at this, I see go-cty. So you can call it whatever you want. I don't even know what it's really called. It's CTY, but in my head, it's the city package. And maybe that's because I'm obsessed with Manchester City, the soccer team, but what are we going to do? And so maybe they are too, right? I mean, who doesn't like City? Basically anybody who likes Liverpool or Manchester United. So, but we digress. Let's see. So with those are the packages that you will need that when you create HCL and use the HCLWrite library. These are the ones that will be needed for what you need to do. In our case, I'm setting up the owner email, and we'll glaze over this for now, but I'll talk about it here in a minute. To get things started, you want to start off HCLWrite by creating a new empty file. This doesn't actually create an actual file on your system. This is just creating a file object. Essentially, in your mind, think of a container that you're going to be adding all these different attributes to it. And that HCLWrite file is your base container inside of what we're filling. And so we have that big base container called the new empty file. And then to actually create the actual file that's sitting on your file system, you'll use the regular OS package that's inside of the Go language, and you'll use the create function and just create a basic file with a .tf file extension. That'll make it so that when the file is created and the file system sees it, it will understand it as a Terraform file that's containing HCL. We check to make sure that there's no errors when we do that. And then inside of the base object that we have here, inside the HCLWrite library, you need to create a body. So the file is your just big nameless container, and then you need to give that container a body. And inside the body, that's how you're going to start adding things that are actually usable. So I'm just going to give it this file or this name called root body. And then in root body, what we want to do is create a new block. Each of the different blocks, because Terraform is declarative, you need to create blocks for each of the different definitions that you have inside of your configuration. Each of those blocks are different. You're going to have blocks that have names. You're going to have blocks that have variables. and you'll have some blocks that are just a single label. In our case, we need to create that top block, which is our Terraform block. And so you do a create new or append new block. We're appending it to the root body, so to the root of our file, and it's just going to have the label or the type of Terraform and nothing else. We'll see why later that we're passing a nil for that second argument. So inside of that block, we need to access its body. If you start noticing a pattern here, we first create like a container of a thing. In our case, we had the root, what do they call it? The root file, the new empty file, right? Root body, or no, root. And then we start talking to its body and we add things to its body. Now, inside of that body, we're appending a block, and then we need to get inside of its body. And so with this, I'm now inside of the Terraform block. I want the Terraform block body, and then I'm going to get to the required providers block. If you've written some HCL before, these labels here will look familiar because you had these at the top of your HCL files and of your definitions. What I want to do here is talk through this block, and then we're going to run this and show you just what that block looks like. I'm going to comment everything else out so that we can see just how that block looks, and then you'll start to see the pattern of how, okay, this is what it looks like with hclwrite, and this is what it's going to transition to inside of our HCL file, or our .tf file. So I have my required providers here, which is a new block inside of our Terraform block. You can endlessly go as far in as you can make it by appending a new block inside of another block. You can just keep recursively going inside of each different block, depending on how deep you want to make your different blocks inside of your configuration. And in this case, I have my TF block. I'm going to add my required providers, give it a nil still, and then get inside of that body of the required providers. And then we finally actually get to the spot that we're going to be creating real information. This is the stuff that actually defines what we're doing. In our case, we're going to be using the PagerDuty provider. That's our required provider. And then the source is available, PagerDuty/PagerDuty. And then this is the version that we want to run. In our case, it's 2.3.0. This is an equals. And that way we can just create that there. As I mentioned, what I want to do now is actually comment out everything else. And I just want to show you what this small bit looks like first. So I have that here. I'm going to go into my terminal here in this window. I'm going to say go run create services. Account owner email declared but not used. Ah, yes. Go has that tendency, doesn't it? If you set a variable and they're like, wait, you're not using it, it basically throws an error, which is good. I mean, it is good because you don't want to have floating variables just sitting out there being created, taking up memory and space, and then not ever being used. But is it kind of annoying sometimes? A little bit. So let's do that. So go run. Actually, just go like that. It created our file. It also outputted it to the terminal. This is just me doing this. If we come down here, this helped me step through how my progress was going. So I just printed it out to the terminal, to the console, so I could see what was actually being written to the file. It's the same exact output, f.bytes, and I'm just outputting it to the screen, but then also writing it to the file. And to show you I'm not crazy or a liar, there is my file, and it has my Terraform block, and then appended inside of our root body, and then I have my required providers appended inside of there, and then I have my PagerDuty block appended inside of there, and then I set my values, my attributes for source and version. In fact, let's do this. Let's put this side by side, and I'll show you up here what the code looks like and then what the HCL looks like on the right. So the HCL doesn't take up quite as much east-west space. So I'm going to squish it over there. And in here, we have our Terraform block, our required providers, all added to the bodies. And then I have this body here that is a PagerDuty block. Its value, this is the first argument inside of the SetAttributeValue, is going to be the label of the thing that you want. And so in our case, this was the PagerDuty label, because that's the only attribute that's inside of required providers that we have, or at least that we have set here. And the provider is the PagerDuty provider. And the value is going to be this object, which is actually a map. And so we take that map, and it's going to be a map of a string and the city value. And inside of that city value, we give it a source and we give it a version. And then each of those fields have this city.string value. This is asserting that the value is a string. And this is the most straightforward attribute type to set. And when you're looking at your HCL, you can see the different strings that you're setting, because you're setting a lot of string values when you're doing Terraform. However, there's going to be times when you're not going to be doing just straight up strings. So that's why I wanted to point out that this string value here is going to be coming through as a value that looks like this with double quotations around it, and it's going to be interpreted inside of the .tf file as a string. And then here, just for making things clean, you have that append new line function, which I enjoy to do inside or after each of the different blocks. So looking at the different services that I want to create, I need to be able to create an escalation policy. And since my account is brand new and I don't have any other objects in it, I need to have an escalation policy. And so I need to create one. And creating an escalation policy in Terraform is honestly pretty straightforward. The HCL over here is going to look pretty good. However, there's a few different pieces of that HCL that are a little more complex than just setting up a string or setting up a block. And so I'm going to now unleash our escalation policy HCLWrite code. And this is going to cause us to have a conversation about different ideas for how to do, you can do a certain thing two different ways. And I'll kind of tell you why I chose the way I chose. And I come here. Oh, I did not want to uncomment that. That is a comment that I want to keep. All right. So in our case now, I have a resource, a new append new resource block. This time I'm going to pass it a second value rather than just saying resource and then nil like we did before, where we created Terraform and then the provider, required providers, and then this PagerDuty block. We're actually going to set it up to where it's going to be a resource block that passes in a variety of other strings. And in our case, it's actually, rather than trying to figure out how many arguments to pass into that append new block function, HCLWrite decided that the first value is going to be just a regular string. That second value of labels is just going to be an array of strings or a slice of strings that basically says, just give us whatever you want. And so if you want to write one that has lots of different labels, and maybe HashiCorp is thinking about the future, and you'll have blocks that has, 5 and 6 and 7 labels. I don't know. Just a wild thought there. So in our case, I have a resource. It is a resource of type PagerDuty escalation policy. And then that resource has a name, and we'll name it EP. That way we can refer to it through the rest of the configuration. We're going to, again, access its body. And then inside the body, we set a couple of attributes, things we've done already. We've done a string. We set it. We've asserted that it's a string val here. And to come to this set attribute value, you can see that name needs to be a string, but then val needs to be a city.value. And city.value can give you, if you drill into that library here, you can actually see, let me actually drill into the library. You can scroll through and see the different values that you could possibly pass in. You have the string value, you have normalized strings, you have an object value, and so on and so forth. And so those values can actually, you'll be using a lot of those as you set up your different HCL definitions. And, but in our case right now, we're just going to use string. And then in this one where we have num loops, we're going to set up an integer. So it's going to be 3. But this one, you'll notice, will not have quotes around it. And then we'll append a new line to that. Inside of that escalation policy, we'll also set up a rule, which doesn't have any other labels to it. And then inside of that block, we're going to set up a delay in minutes, which again is just a string, or I mean, not a string, an integer. And then the target block is another definition or another attribute of the escalation policy. And here we're going to grab the target. We'll set a string value of type, and the type is a schedule reference. And then this is where things get interesting, because in this case, with an escalation policy where you have a target, if you think about when you're setting up your PagerDuty account, that escalation policy, the target is either going to be a schedule or a user or a team, I believe. In our case, we're going to have a schedule. But to be tied to that schedule, you need to know the schedule's ID. Simple enough to do in HCL, right? You can use it as a resource reference. However, to create that resource reference, that was a little tricky. And so that one took me a little bit to find out. So there's 2 different ways that we can do it. The first is actually one that I have highlighted here. I'm going to actually... we're not going to run it. We'll just leave them both. So here I have the HCL syntax unknown word. Interesting, because it works, I promise. And so that has a schedule reference. So the type of schedule reference. Inside of the schedule reference, we need to do one of 2 things. We need to create an ID for that target, and it's that ID of the schedule. So in our case, we can create a token using this function called the SetAttributeRaw. What this does is it's basically saying, I'm going to set an attribute right here. I'm not going to set it as a string. I'm not going to set it as a number. I'm going to set it as a raw value, whatever you want to send me. Excuse me. And so I'm going to set it whatever you send me, but you're going to send it to me in an array of tokens. The tokens are part of the hclwrite library that each have a type, and then they each have an array of bytes that are the value of the thing coming in. And so with type, you need to have this value set, and this is where the HCL syntax comes in. With HCL syntax, we can look at this type. No, we can't, because it doesn't know who I am. There we go. Now it knows who I am. If I come into token in intent or ident, it's this type of token here, which I have interpreted, and anyone watching this might know differently. Post in the chat. I'm happy to learn more. But from what I understand, this the token ident, is actually just for any string variable, right? Any letter, any number, and it's going to be wrapped in quotes probably. But then when you start looking through all these other different token types that you can think of that you would have in your HCL code, you can start thinking, oh, this is how I can construct my various values. Now, the part that I'm not super clear on is that with this token ident, I can also use special characters, because I used, if you look in my value over here, I use dot, even though dot is one of the token types here. I could have done a token dot, but I just instead, I have this byte array that is passing in. This is our resource reference referencing the ID in the schedule. And so I have the variable value here, PagerDuty underscore schedule dot foo dot ID. I could have also done .tokens in there, but I didn't see a reason, especially since, as you'll see, the result is exactly what I want it to be. So in this case, if it's going to be exactly what you want it to be, you'll never need to, expand on whatever values are there. I don't see a problem with doing this. However, if you see a problem with me doing it this way, please let me know. I'm happy to learn more. And so in this case, I just needed a variable value for the schedule.foo, which is what we're going to define here in just a second, .id. And with that ID, we're going to take all these schedule tokens, this array of tokens, and we're going to pass them in to SetAttributeRaw. And in that raw attribute, we're going to have that value that we need. On the flip side, there is another way to do this exact same thing. And this is by using something called a traversal. Traversals, and what I'll do is I'll open it here, I'll run it once, and then we'll have to run it back because, we don't want it to not work when we actually run the Terraform. Yeah. Okay. So we have this HCL reversal. I don't know what. Yeah. Okay, good. And so a traversal is a variable, or it's a type inside of the hclwrite library that allows you to create something that is a chain of values. So in the case of writing one of these variables, a traversal is going to be something that says, okay, this is the root of it, this is the next traverse, and this is the next traverse attribute. And you can set that up through this traversal object here. So I have my set traversal ID, there's my IDs, and then I define my traversals here. And I have PagerDuty schedule, I have foo, I have .id, and then it just assumes the dots in between because it's traversing through that value. So let's have that. We'll leave that right there. And I'm going to run this. I've actually never done this split screen. So let's see if this actually does what we want it to do. Because the file already exists, it's not going to recreate the file, but it is. Yeah, that was nice. Just appended what we wanted. Perfect. So we have our value there. And then up here, I have my escalation policy. It's defined with my EP, my name, my num loops. See how my number came through without any quotes. That's a good thing. And then I have my rule block. And then I have my ID down here. The odd thing is I set ID twice and it didn't. Interesting. It didn't set it twice. That's what happens when you do stuff live, right? When you start making changes live and think, oh, I'll just try this out real quick, see what kind of result this gives me. So what I'm going to do now is I'm going to take this. I'm going to change the name of that, and I'm going to call it TID as traversal. In fact, I'll call it Travid. Travid. There's a new name for you. Okay. I'll run that. Yeah. Okay. And so that created, see, so that's another benefit of the library right there. Actually, I just stumbled on it. The library understands generally what should be happening inside of a block. It knows that there should not be two IDs. It knows, hey, I'm probably going to take the second ID. To prove my point, actually, now I'm totally in this excited mode where it's like, okay, let's try this. Let's do food. And I bet that it's going to give us this value, but with the second definition. Yeah. Yeah. So what it does is it just overwrites it, but it understands that I don't need two IDs set here. You obviously made a mistake. So I'm overriding what you've previously defined. I'm overriding what you did here with EP rule target body set attribute raw ID by passing in the tokens. And then I said, I'm going to set the ID and pass in the traversals. The code thinks, or the library thinks, hey, that second one's the last one I've heard about. So I'm going to go with that last definition that you mentioned. So that is fascinating. Now, as you might have seen before, I did not go with traversals. I had traversals actually commented out, and you'll see why when I'm setting up my schedule. I feel like the tokens are a little more versatile and a little more scalable when you're actually building out your references that you have. So I'm going to take this out. Probably change that back to foo just to make sure I don't do something silly in the future, like try to use it. That'd be bad. But I did need to append that new line right there. Good. Let's see with this. So now I want to set up a schedule with HCL. And that one has 2 sets of comments, so I'm okay with that. I'm going to come down here. Schedule has quite a bit of stuff going on, but that's okay. We'll kind of skim through it just a little bit, just to talk about the things that are new rather than rehashing over the old stuff. We'll just glaze over the old stuff. Right. So you've seen a lot of this before. You've seen this AppendNewBlock. You've seen the body. You've seen these string values that are asserted for our name and our time zone. We're appending. Schedules have a lot of blocks and a lot of embedded blocks. So you'll be doing that a lot when you're building a schedule here. And so this layer right here is just fine. Has a regular string value to sending up a couple of dates. It has seconds, which is another number value. But then we get down to this next reference, which is a different type of reference, because the last one, we were just trying to get the single schedule ID to set up our escalation policy. But with the escalation policy, but inside the schedule, we need to set up a target that is a list of users. So we need to get a group of users into our schedule, or at least we need to be able to. The API is expecting a group. So if the API is expecting a group, that means the API is expecting an array. And so setting up an array, you can do a couple different ways. I could have used that traversal, I think. Actually, I don't think I could have used that traversal because I don't think I could have done these blocks. And so maybe I could have done a traversal inside of here. But if I can already do this, where I'm making my token be this block, this string block, then I don't need to do more, traversal code that would confuse things and make things a lot more complex. I'm going to just do things that are straightforward. In this case, I have a start of my array. I have my value here, and then I have the close of my array. If we had a lot of users, you can start picturing this now. Just to add more users, I'm just going to add more blocks, just like this one right here. And I'll list all of the users out that I want to do inside of my definition here. And so by having this, we can do that. In fact, and as I was talking about this, I was thinking about, well, what about commas in between the users? But I'm pretty sure I can come up here, and see there's a token comma type. And so you can loop over all of the users that you want to add to this schedule, and then you can just add them into this block. And so this token approach is the one I like, and this is the one that we're going to talk about, or that we're doing today, because I like its versatility. So I have my users. My user is going to be me, because I'm the only user in my account right now. And because I'm the only user in the account and I'm the account owner, I'm not going to be managed inside of Terraform, right? I just need to get the values that are already inside of PagerDuty and get them into Terraform state so that I can add myself to this schedule. So that's why I'm going to set it as a data, and then we're going to pass those users in. And in this case, I put a new line. I give it a restriction because my schedule layer needs a restriction. And these values are the same, that are the same types of values that we've already seen before. We've seen some strings, we've seen some numbers, and so we'll glaze over that part. And now, in this case, I need to grab that user, the user that I was referring to up here, data.user.me. I can grab it here, down here in the body of root. I'm going to put another block that's actually at the root of the document, same as my schedule and my escalation policy. And I'm going to give it be part of a data block. And I'm just going to be a user, it's going to be me. And I want to grab that account owner email. Why is it red? Remember when at the very beginning, when I tried to run all this, it said, hey, you're using a variable that you're not you're setting a variable that you're not using. Well, now we're using it. So let's set that. We'll come down here. We have our email. And then that's it. So let's run this and see how this looks now. Go run away. Just kidding. Do that. We have our HCL file update over here. And we have a beautiful looking schedule. Our schedule has a name, a time zone, a layer. That layer has a relatively recent start date. And then we have our users here and then our restriction block. All of this looks like really well formatted HCL. All we had to worry about was setting up these blocks and giving the right data. The HCL library understands exactly the type of file it needs to be building and exactly the type of values it needs to be writing for that syntax to work when we actually run Terraform apply. So now that we've gotten all of those different definitions put into our HCLWrite code, we still need to define our services. So I'm going to come down here to my services, and this is kind of where the magic-y stuff happens. The whole impetus, the whole reason why we were doing this is so that we could write a lot of services. I could create any number of services I wanted as long as I could do it really quickly and automatedly. Because not only did I want to create them quickly, I want to delete them quickly because, you know, after you test something out and I'm learning from my mistakes that I talked about at the beginning, where I had a big messy account full of lots of random information. Well, now I can spin this stuff up, run it, and then quietly make it go away when I'm done. So what I have here is I have my loop. There we go. And in my loop, if VS Code would just not be so helpful, that would be really, really great. All right. I have my loop. It's creating my service resource here. And my service resource has a name. It has, which is my me service label. I'm going to give it just a number of whatever service it's on. In fact, rather than 50, we're going to go nuts. We're going to create 150 different services here. And it's going to loop through that. I'm going to use my preferred way, my preferred notion of using the token model. So using the tokens objects, and then using the SetAttributeRaw function. This is the way that I preferred to do that I talked about before. And I'm going to set the escalation policy, the one that we created. I'm going to grab that value so I can refer to that. And with each one of those, I'm going to set my escalation policy. So relatively simple setup. This is our bare minimum of what we need when we're setting up a service. And so, but now I can create 150 of them really rather quickly. So I'm going to run that code. I'm going to pull this over here. We'll hide the recipe. I always think of coding as recipes. I guess I'm weird like that because I like to cook. All right. So what we have here is I have my services. You can see at the bottom this going on where I have my service created, give it a value, a variable name, a reference label essentially to make it so we can refer to it if we need to. And then it's the name of the service and then the name of the escalation policy or the ID to the escalation policy. Those escalation policies are valid syntax to the resource reference. And so that gives us 150 new services inside of our PagerDuty account that were, the HCL was written in a couple of seconds. Obviously we had to put together the HCLWrite code, but you get what I'm saying there. And so, but now you're sitting here thinking, yeah, that's nice, Scott. It looks pretty, looks great, but does it work? So now I'm going to pull over let's look at my PagerDuty account. I believe it's over here. Oh, it's not. It's right, because Chrome was giving me problems. All right, let's see. Is Chrome going to still give me problems? Yes. Why is Chrome giving me problems? All right, let's do this. I wonder what's going on. happens if yeah, new tabs don't work. Huh. Those are all dead. All right. Well, Firefox it is. Let's do this. Promise Mozilla did not pay me. Wow. This is all sorts of falling over. Okay, so that didn't work. Technical difficulties on my end, but let's see if I can make things run and make things happy. I'm not sure how we're going to get into this account because I don't remember my password. That's a problem. Well, what we'll do is I'm going to make my terminal basically full screen here. And I'm going to run my Terraform commands. So we want to look at our Terraform commands and see how that runs. And you'll see how the API will actually do it for us with the fact that I can't get into my account at the moment because Chrome is busted. Let's see what's going on with that. So I'm going to take this, do my Terraform apply. It wants to create 152 new resources inside of my PagerDuty account. Inside of that account, we have those 150 teams. Then we have that service. No, not the service. We have that schedule. And then we also have that escalation policy. So that 152 sounds about right. And we can glance over it and say, okay, yep, that service looks about right. And we'll go ahead and type yes. Then we'll take a sip of Dr. Pepper. All right, Terraform tells us that everything's happy and that it's all good. So what we're going to do is that since I can't get into my web UI, I'm going to go through the API. Okay, make sure that just a second. Always got to take the secret stuff off the screen, right? I get my API token here. Oop, don't do that. Great. Okay, so I called the API on my account, and we don't care necessarily about this. What we care about is that we have a limit of 100, but we have a total 152 services that are created. And so we already had 2 services sitting in that account before, and now created another 150. So hopefully that shows a little bit, just a different way to think about how to write our Terraform code, our HCL code, when we don't have to necessarily do things by hand. We can have various tools that can help us do things a little more efficiently. If you want to see a little bit more about what I've been doing, and I'll drop these in the chat. I wrote a couple of blog posts on the topics that we talked about today. The first one was when I very, very first discovered the library, and it basically talks about how to set real basic values inside of there. And so we talk a lot about just about setting up the blocks and the strings and the numbers, and that's it. And so that one it's great. It shows just the bare minimum stuff. And then the second one over here, I just came out with the other day. Super excited about this one. And this is the one where I kind of go into the resource references. Copy that. And so if you come down here, so you create Terraform Resource References in Go with hclwrite. This one goes into more of the details about my exploration of using tokens, my exploration of using traverse, using SetAttributeRaw, and just talks about how you would do that using this library. And so I'll drop that into the chat as well. And then finally, all of these, I have definitely saved the code over on GitHub. So if you want to look at this code, you can find it here. There's a library called Create Terraform Files in Go. For now, it's sitting in my personal GitHub repository. That's just where I started it, and that's just where it lives for now. But if we ever change it, we'll be sure to reference it. So you can find it there as well. But thanks for joining today. Hopefully you learned a little bit about writing using Go, using the hclwrite library. And please, again, come join us at our Terraform Roundtable on April 26th. That's a time that you all can get together as users and talk amongst yourselves and learn from one another. And then there's always the PagerDuty Garage show that's at the beginning and ending of the week here on this channel. Have a wonderful afternoon, everyone. I'm Scott McAllister, and I'm wishing every one of you an uneventful day.